Okay, let's go through simple linear regression question using minitab. I've done this in class, but I want you to be able to remember the details. So I'll go through this example that we do in lecture. Okay, so let's imagine that X is some sort of body mass index collection, and Y is a measure of the cholesterol. Okay, so we've got two variables. This is bivariate information. That means there's one population and you collect two variables from each person in the one population. So you have paired data here. You've got person one's X is this, person one's Y is this, person two's X is this, person two's Y is this. These are paired. Okay, so here the idea that we want to do, of course, is find if there's a relationship between these two numeric variables. We do this with simple linear regression. Okay, so here I've got, in Minitab, I've got this data already prepared for you in D2L. This is column X, this is column Y. Okay, let me just start with a graphic. We probably want to do a scatter plot between these two, X and Y. Okay, let's just start with the simple. It's asking for the Y, which is called the dependent variable. I've labeled it Y here, but it could have also been labeled just cholesterol. And X, which is the prediction interval, or the prediction variable, sorry, and it is BMI here. So if I press OK, you can see this is, I've got X's on the X-axis, I've got Y on the Y-axis, and I've got a scatter plot here. Okay, you can also have Minitab do a regression line with your scatter plot just to see what it's going to look like. But so that gives you a visual to see, you start understanding if there's a relationship between the two variables here. Okay, before we look at the regression line, one thing we want to ask ourselves is how does Y respond to X? So as X is going up here, what's generally happening with Y? As you can see, as X gets big, Y seems to be increasing. Okay, so this is called a positive relationship. As X gets big, Y seems to get bigger. The biggest point is here, the smallest point is here on this angle. This is an uphill or a positive relationship. You could also have here, if X is getting bigger and Y is getting smaller, you could have this downward slope where, of course, you've got a negative correlation. Okay, so that's step one. Step two is, it might be a little bit easier to see with this line. Step two is to decide just how close these points are to its line of best fit. So here we don't have any points falling exactly on the line, so it's not perfect, obviously. A measurement of the strength of this pattern is called the correlation. Okay, so let me show you how to do that with Minitab. Let me just move this down here. In Minitab, you can go to basic statistics and go to correlation. Okay, here it doesn't matter what order you put it in, but I want the X value, I want the Y value. And I'm going to talk about Pearson's correlation. There's also Spearman's rho. We're not talking about that in this course. We're just talking about the correlation, which is a measure of how these points follow a linear pattern, a line, a straight line. Okay, so here we've seen how to calculate this using formulas. It's a little bit convoluted, but I'm just showing you how to use the computer. So here R, or the correlation, is allowed to be from -1 to +1. -1 would mean all the points fall perfectly exactly on the line in a downhill slope. +1 would mean all the points fall exactly on the line in an uphill slope. Here, 0 would mean there is no relationship, positive or negative, between X and Y. Here we've got a 0.7, so here, if you think about it like a grade in between 0 and 1, or about 70% or something like that, you can get an idea for just how far these points are away from their line. Okay, so this is called the correlation. Okay, so growing from that, we want to actually find what is the equation of this line. So let me just quickly go back and do some things. So here again, just a quick refresher. To find the correlation, this is the formula that you would need to perform. I've just shown you how to do it with Minitab. Okay, Also, you might be interested in some of these summarized statistics. Okay, so here, if you were using this formula, you would need the sum of x times y, you would need x bar, you need y bar, you need s of x, you need s of y, and you need the sample size. Okay, so how do we do those things? Well, first I'm going to make a column here that is the x's multiplied by the y's. Okay, so you could go through with your calculator and just multiply these two and put the product here, multiply these two, put the product here. With minitab, I'm just going to do that quickly. I can say, store the result in column 3. So I'm going to store things in this column. What am I going to store there? I'm going to store column 1 multiplied by column 2. Okay, so here is the product of these things. And then I can find like the sum. I can find a whole bunch of different things all at once. Recall we've already talked about doing this, stat, basic statistics, and I can go to displaying the descriptive statistics. Okay, so here I'm interested in column 1, column 2, and column 3. What am I interested in? Well, I'm definitely interested in the average, so I want x bar, I want y bar. I want the standard deviations, I want s of x, I want s of y. I want the sum. Okay, and that might be mostly what I'm interested in here. Okay, so here you've got, this is x bar, and this is s of x, standard deviation of x. Here's y bar, here is s of y. This would be the average of the products and the standard deviation of the products, but really what we're mostly interested in is the sum of the products. Okay, so this value and these 4 values I'm terribly interested in, because when I go to my notes, here's the sum of the x and y's. So I found that was, sorry, where am I? That's right here. This is the sum of x times y. N is just the number of points. So what is n here? N is, looks like there are 10 x's, there are 10 y's. So n is the number of pairs, so n is 10. Then I've got x bar and y bar, which of course are just the averages of x and the average of y. So here's x bar, here's y bar. Then I'm going to divide that by n minus 1, which would be 10 minus 1 or 9, times by the standard deviation of x. Here's the standard deviation of x, and also multiply by the standard deviation of y. So you could calculate with some summarized statistics what R is, but we also had minitab just do that for us. Okay, so here are some of the data that you can check out. Let's continue on then, actually performing this regression. I just want to make sure. So here, we go through this step by step through the notes, but here you can find this value here is the approximated slope. This value here is the approximated y-intercept. Okay, so how do I do that with minitab? I can go to stat. I'm going to perform a regression. It is a fitted line regression here. I like to look at the little pictures here. I want the straight line regression. And then minitab asks you for what is the responding variable. Okay, so this is called the dependent variable or the responding variable or your y variable. Okay, so here is where I want the y variable. Okay, it's the responding variable because it's usually the thing we don't know or the thing that's hard to understand. Here we're assuming that it's easy to have the body mass index, and then from the body mass index we are predicting the cholesterol. So why is the cholesterol here? We're assuming that we know the body mass index. If we know the body mass index, what do we have to do to get the response, which is y? So here I've got y, I've got x. I'll press OK. Okay, so here the last thing that minitab gives you is the regression equation. So here is the y-intercept plus the slope times by x. Okay, so this is the equation. You can also find this equation by looking at some of the other details. Okay, so minitab tells you the coefficient of the constant, also known as the y-intercept, is 58.3, as you can see here. It's 58.3. The coefficient of, here I've called this term x. The slope, the coefficient of the x term, is 4.52. So this is the slope. Okay, what these things mean is, here I'll talk about the slope. Okay, so for every increase in one unit increase in x, here is the body mass index, so I think that's in percentages, I don't know. So here for every percent of body mass index, we can expect the cholesterol to go up by 4.52. So if you had a guy that came in with 70 body mass index, that seems awfully high, but 70 body mass index, and you've got another person with 71 body mass index, that's just an increase of 1 in x, then the increase in y between the two you would expect to be 4.52. Okay, so for every unit, 1 unit increase in x, you expect y to increase slope amount. Okay, here what the y-intercept is telling you about is the initial point. Okay, so here the starting point. If x was 0, so sub in 0 for x, of course 0 times 4.52 would be 0. Then where we start, if x was 0, if your body mass index happened to be 0, then you would expect to have a cholesterol level of 58.3. This is actually theoretically impossible. I mean, you could never have a body mass index of 0, but we're assuming that if you did, then the amount of cholesterol that you would have would be 58.3. Okay, so there's some other things here. We're going to talk about this in class. This is called R squared, or the coefficient of determination. If you take the correlation, which is R, and you square it, you will get this R squared value. Okay, so let me just remind you what correlation was. Here we had correlation was 0.707. If we squared that and then made it into a percentage, we would get 49.99. Okay, what this says, what the coefficient of determination says, is very specific. Okay, so you need to pay attention. What it says is that 49.99% of the variation, okay, of how much y varies, 49.99% of the variation of y is explained by this linear regression depending on x. In other words, x is explaining 49.99% of the variation that we see in y. Okay, so it gives us a measure of how much x is doing to predict y. Okay, so that is R squared. That is called the coefficient of determination. Okay, also that what we want to talk about in class, let me just go to it again. If we're doing, here's how you find the regression. If we want to talk about the residuals, okay, so here all I did, let me just show you again. I went to graphs, and I want to go, if I want to have a residual plot, I want the residual versus the fit. Okay, this will give us our residual plot. Okay, and residual plots are very important in finding out if x is doing a good job to predict y. Okay, because good is very arbitrary. How good of a job really depends on what you want, what you mean. When we're looking at the residuals, what we want to see is a random pattern. Okay, we don't want to be able to see any sort of pattern here. Okay, some examples you could see. So I think this is pretty random. Looks pretty random. If there was a curve or if there was a line, these things are bad. Okay, if you have a specific shape pattern, a curve or a line, what that means is that x is not doing a good job of predicting y in a linear pattern. The line shape is what's an issue if your residual plots show a line or a curve in them. The other thing that we want to make sure for is to not see any wedges or triangles. Okay, so here, do we see that this, is like a crescendo? In this case, like here, it's getting a little bit wider, as you can see. In general, do we think that this thing is, starting narrow and then getting wider and wider, or is it starting wide and then getting narrower and narrower? Okay, so do we see wedges or triangles? In this case, you might see a little bit of a triangle here, but I think overall, again, this is pretty random. If you do happen to see this wedge-like shape, that is also very bad. What it means is that you've got non-consistent standard deviation throughout your data, which is called heteroskedasticity. Okay, so what we want for the regression to be doing a good job is homoscedasticity. We don't want to see any wedge shapes. We don't want this thing to be ballooning out or to be getting smaller, crescendo or decrescendo if you're musically inclined. We don't want to be seeing that. If we do, then that means that our regression is not going to be terribly accurate either. Okay, so this is how you can perform some of the linear regression requisites for this 213 class using minitab.